This is problem number 34 from the June 2017 Geometry Regents exam. In this question, we've got a cylindrical fueling tank, and it tells us that it holds a maximum of 20,000 gallons of gasoline and it has a length of 34.5 feet. What we need to do is find out how long a pole needs to be in order to reach the bottom of the tank and still extend 1 foot outside of it. So this little tiny distance here is 1 foot. And what we'll be able to do is if we can find out the diameter, that distance there, plus 1, that'll get us our answer. So the first thing we need to do is make sure we're using the same units in all of our measurements. So, and they give us a little hint here that 1 foot cubed equals 7.48 gallons. The first thing we should do is convert the volume of the tank, 20,000 gallons, into feet cubed. Let's go ahead and do that over here. So because 1 foot cubed equals 7.48 gallons, all we need to do is take 20,000 and divide it by 7.48, and that'll get us our volume in terms of feet cubed, which is 2,673.8 feet cubed. Now we can use the volume formula of a cylinder to our advantage to find out the radius of this cylinder. So the equation would be the volume equals pi r squared h. Now we know the volume is 2,673.8. And we know our height is 34.5. So what we can do at this point is we can divide both sides of the equation by pi and 34.5. And from that, we get that the radius squared is equal to 24.39. If we square root both sides, we'll get that the radius is equal to about 4.94. So to find the diameter, we would times that by 2, and we get 9.9. I'm just rounding to the nearest tenth because that's what it tells us to do. And just like our original strategy was to find the diameter and add 1 to get that total distance of that pole. So the total pole length would be 9.9 plus 1, which gets us 10.9 feet. All right, hope that was helpful, and thanks for visiting JD's Regents Preparation.